the today's resource person has got very experienced uh, member, not only in technical aspects, she is also very important uh, member and heading the syllabus reviews committees for a very long period. And particularly this AI quantum, she is heading all this curriculum design and development. So it is very important for all the faculty as well as students because you can directly share this link to your students for the direct benefit of students. Before Madam's presentation, I would like to introduce Madam to all the audience because maybe you might have known Madam since long days. Professor V. Valli Kumari is a professor of computer science and systems engineering at Andhra University. She has an experience of over 30 years in teaching, research and administration. She is presently the Dean University Research and Development and HOD of Computer Science and Systems Administration and Engineering at Department of Andhra University, Computer Science. She has published over 200 papers in national and international peer-reviewed journals, including the Scopus H Index of 13, and has over 25 research scholars awarded with a PhD. She has executed several projects from DST and MIT. She is also a very active member in quantum technologies and quantum algorithms, and also submitted proposals for the projects of crores of rupees for quantum algorithms. She is also the chairman of the Computers Board, which has framed the APSHA syllabus, including AI fundamentals and AI applications. Apart from this, I would like to introduce Madam as an able administrator. I know her since many years, and she has been the CEO of a very important Innovation Society of Andhra Pradesh.
Yes, sir. Audible, sir. Audible, sir. Live is going, sir.
పోయిందా సార్ పోయిందా హలో
No, sir. No, sir.
ఆడియో
Audible, sir.
ఆడియో
Audible,
రావట్లేదండి ఆడిబుల్ ఉంటారు బట్ ఐ థింక్ యూట్యూబ్ లో రావట్లేదు
No, sir. Wasn't, sir. So please go ahead, sir. Go ahead, sir.
ఇది వేరే ఇది వెబినార్ ఇది సారీ
So please go ahead, sir.
Yeah, thank you. No, these persons confused because a parallel program is going on here on a par. So I would like to introduce Madam further because she has been an able administrator for the long period, even previous governments. She worked as the CEO for Innovation Society of India and also worked as Vice Chairperson in AP State Council of Higher Education. And apart from this, she is also a member, a very active member in so many DST as well as other mighty projects. She has been helping many young generation students who are into the computers, and she is handholding many and so many students as from university and particularly from her internship. They have gone for abroad. Even many students are there in US and Europe and Australia, etc. This is the profile of today's resource person, and maybe all AP faculty members might know her and kindly utilize this session because this is going to be very important as per our curriculum, because she is the main force in designing this curriculum, both quantum technologies as well as AI, particularly the applications part. With these few introductory words, I now welcome Madam. The floor is open for you. You can take the session, and you may take up to 1 o'clock if you are comfortable, or otherwise the scheduled program will be 1.5 hours, Madam. I welcome you, Madam. Please, thank you, and namaste for accepting our invitation to take this session webinar. Thank you, Madam. Madam, now you are the presenter. You can present your slides if they are available. Go ahead, madam.
అన్న ఏమైనా మాట్లాడాలనుకుంటున్నాను.
Can you hear me?
Ma'am, you can share your presentation, ma'am.
Yeah, I'm doing it. Yeah. Is that fine, please?
Ma'am, visible, ma'am. Your presentation is
Is
visible.
that okay? Can-
Uh,
Okay, thank you. So, good morning, everyone. I'm very happy to meet you all uh, for this talk on building AI models for prediction and detection. So, I have chosen a few topics from the syllabus we had framed earlier. So, I'll try to, share with you a few practical aspects how data can be handled and how AI models, simple AI models can be built. So my target for today's talk are not the researchers or the faculty or the PG. I am targeting students. So as per the advice of Anil Garu. Just a second. So now, as you can see, so a whole of my talk will be covering these aspects. Here and there, we'll try to modify as required. So I'll cover aspects like how to prepare the data, maybe how to generate the data as well. But most of the time, the data is available in several portals like Kaggle, okay, and several other portals like UCI and stuff. So we'll first understand how the data is prepared and how the data can be visualized. And then we'll try to find out how to divide the whole data into train data and test data, which I'll elaborate later on. And we'll try to look at a few case studies which we have already given in the syllabus. So we'll cover a couple of them and one of them outside. And I'm strictly following the tools that are mentioned in the syllabus. And I'll also give you one Python, model, Python-based model for prediction and detection for people who would like to write the models, build the models from the scratch using the Python libraries. So, yeah. Now, why AI is essential for non-engineering students? Like debate whether non-sciences students really need AI. Yes, over the past few months, you must have observed how AI has penetrated into our lives. So, be it a mobile app or talk about any tool, people are after AI. They deploy AI models in every software application that we are presently using. So, any app that we start using, the vendors or the developers, they are actually performing a lot of uh, you know pattern recognition, lot of interesting trends they're trying to study. So the career advantage for any uh, UG student and a non-engineering student, so is like in banking, in pharma industry, in management. So we resumes, even the candidates, they're mentioning that they have knowledge computers, software, certain softwares, and usage of AI tools as well. Yeah. So there are a lot of applications like BSc sciences streams. It can be biology, botany or zoology or chemistry. So, lot of applications like X-ray images, classification, COVID data. You know how classification or detection is done. Drug discovery. Uh, Agriculture. AI is being used like anything. Then BCom. So certain typical applications are stock market prediction, automated accounting, like Tally now comes with AI. Similarly, even arts courses, they're too much into the usage of AI. So it's not exaggeration if I say, none of the articles these days uh, uh, we don't find any articles which do not have a flavor of ChatGPT or such kinds of tools. So AI is there in journalism already, sentiment analysis, social media analytics. So all of these, they're part of the courseworks. And one advantage we have over the 4 5 years is that uh, people don't have to be coders to use AI. Normally, people think AI is all about coding. Yes, we do have lot of sophisticated programs uh, written for AI, but all need not be coders. Like uh, to use a bike, you don't have to be a mechanical engineer. To use a car, you don't have to be an automobile engineer, right? So it's to live in a house, you don't have to be a civil engineer. So to use an AI tool, you don't have to be a coder, right? So there are a lot of tools like Orange, Canva Magic, Teachable Machine, and there are many specific tools for like for drug discovery, for stock market prediction, time series, database models. Okay, you have a lot of tools, specific tools for specific applications. Yeah, in the syllabus we have a few tools like what I mentioned here, and I have to thank Professor Madhumurthy Garu, Chairman APSHE, who has given us the opportunity to frame this syllabus. All of us, the names listed out here, are our team members, and uh, the team at APSHE like Anil Garu, Srirangam Matthew Garu, and a lot of others have really put very hard effort to see this AI syllabus to the place where it is now. I thank them all for giving us this opportunity. Yeah. So we'll slowly go through the tools that we have prescribed in the syllabus. I'll just demonstrate you a couple of tools. Maybe in the coming weeks, so other people of the team will, make you learn other tools as well. I'll cover a couple of exercises given in the labs too. So Orange data mining tool is one tool specified for the lab. So I would make you walk through certain features of this. So it's an open source machine learning and data visualization tool designed for novices and experts alike. So, but the advantage is that people who do not have any knowledge of AI, any knowledge of coding, can still build models, AI models. So the advantage is it's all user interface based. You don't have to go to the terminal and type, your program instructions. You just need to drag and drop the widgets. So this tool allows users to build AI models, as I told you, without writing a single line of code. So there are a lot of features: drag and drop interface, no coding required. There are about 100 plus widgets for data visualization and modeling, and the visuals are linked. Okay, what does that mean? So if you have a table and if you have a graph, okay, if you're selecting some point in the graph, those rows in the table are highlighted. So that is like those visuals, two pictures, okay, they are linked to each other. They're not, static images. They're dynamically, like if you select some rows in the table, those things only are displayed in the visual graph. So like this, you select any widget and link it to some other widget or module, and then you can see there is dynamic interaction between these two. Yeah, it supports image analytics, text mining, time series data, whatnot. Lot of features are available in this tool. And above all of these features, free to use for students and researchers. So it's no code interface. What is no code interface? You don't have to write any programs. Okay, just you can build models by dragging and dropping onto the Canva. So those modules in which the code is embedded, like when you click on that widget, some code which was written by the Orange people, it automatically, runs. That is the advantage. So it's the perfect tool for non-programmers to understand the complex AI concepts like clustering, classification, training, and test data split. So you can visually explain all these concepts. And as I told you, there are 100 plus widgets already available. And there are certain categories, like for data, you have certain widgets. Okay, for loading the data. So what is loading the data? You can have an Excel sheet or a comma separated value sheet, and you can upload it to the tool. Okay, you can load it, or you have some already available data sets for, it's toy data sets are already available. You can make use of the data sets that are there in the tool itself, that come along with the tool itself. Or you can have your own customized tailor-made data set and you can load it into the tool. Then you can visualize the data. You can draw graphs, you can draw plots, scatter plots, box plots, you can draw histograms, okay, and all such visual images for analyzing the data. And there are a lot of models which are already written for you. You just need to drag and drop that widget into your network circuit and then start using it. That's it. You don't have to understand what is there in the SVM, okay, or a tree model or a linear regression model or an AV based model. You don't have to know. You just understand the concept. That's it. You don't have to write the program for it. Just use it by dragging and dropping into, and then you have different metrics for finding out the accuracy of your model, right? So everything is available in the model. Like for example, these are some of the widgets, right? So you can have a file. Okay, you can upload it from your hard disk. Then a CSV file import, and certain data sets which are already part of the tool. You can have SQL tables. So the SQL tables is like you can generate data from certain portal, certain website, or certain other desktop application, export it as a SQL table and then use it out here, right? You can have many such things. Like you have something called as ranking. So what is data basically? What is data basically? Data means a set of rows and columns. When you give a very abstract definition, it is a set of rows and set of columns. It's like a matrix. Okay. So something like a student database. How is it like? You will have, say, if in your class you have 60 students, then there will be 60 rows in the table, and then there might be several columns. The columns can be your hall ticket number, your name, your marks in subject 1, marks in subject 2, 3, and so on, right? So like this, you can have several rows and hundreds of columns, right? But all columns are not important for data analysis. So what do? You pick up the best ones or the most promising ones which will help you in classification or or whatever kind of a model you're building. So you can choose only those columns which will be helpful for you to make a decision. Okay, so say for example, you would like to go from some place like Madilpalam to say Rishikonda. So for going there, you have several parameters. The parameter could be price, okay, the mode of transport, right? Whether it is like a friend's bike and you pay for it, or Rapido. So you have several features, several columns by which uh, you need to make a decision whether to, uh, go to that particular place. Okay, what is the criteria you would like to choose? So something like, of these 10 parameters or 15 parameters, you may choose, like by auto it is 10 rupees, so you would like to go by an auto. Okay, so what I'm trying to tell you is when you have 100 features or a lot of features for decision making here, the price it becomes the most important criteria for you, and maybe the time in which you are trying to reach to Rishikonda. Okay, so time and price are major criteria, not the model of the bike or other parameters. So you try to give the ranking, like which parameters contribute to your decision making. For that, we use this rank. And yeah, you have what are called as transform gates. So you can take out a sample of data, select the columns, uh, select only the rows or transpose, split the data, merge the data from received from more than one source, okay, concatenate the data, lot of stuff, okay, group by, aggregate, lot of stuff is available. Then we have visualization. So data, when you see in the form of comma separated values, you can understand very little about it. You'll know how many rows are there, how many columns are there, and maybe the maximum value or the minimum value or a repetition. Only a few things you can derive from the data. But then visualizations are the best things that are possible, the best aids that are available for any decision maker. Okay, so you can have a scatter plot or a line plot or a bar plot to understand your data. Okay, all these are available in this, and different models are already built for you. You just need to apply your data, subject this model to your data, and then get the decisions. Okay, so you have a lot of them, uh, KNN, SVM, random forest, then linear regression, logistic regression, lot of stuff. Then evaluation. So once you build a model, the next thing you would like to know is how well your model is performing. Okay, so you like, for example, you have a bunch of fruits in the basket. Now those fruits, you have guava, you have apple. Okay, now when it comes to a model, okay, so you're pushing all those fruits to that machine, that model. Okay, so you have some image capturing device, you'll put that fruit before it. Now it scans and says it is apple, it is guava. Okay, or it says it's apple, it is not an apple. So in that is called as binary classification. When you say it is an apple or it is guava, you say it is multi-class classification. Like this, it may so happen that when you build a model, okay, uh, certain models may classify a guava as an apple. So because certain apples are green, if you're giving priority to color, then it may so happen that guava may be predicted as an apple. So that means model is not performing well. It needs more training, maybe more parameters. So the data that you have given is not sufficient to build a better model that can predict with higher accuracy. So what is done? You need to evaluate. Okay, just like when you're taught in a class, you're always given a test. Okay, so it's the same. Evaluation is the same. For a data, remember, there can be multiple models. Same data, there can be multiple models that can be developed. So it all depends on the coefficients or the weights that are allocated to the models. terms. Well, anyway, we'll not get into that stuff. So just remember, any model, when it is trained, you need to evaluate it. You're taught a subject and you are given a test to know how well you are trained. Just a second. Yeah, and there. Yeah. You also have unsupervised learning models. Right? We don't have all of this stuff in the syllabus. So, but for those of you who are interested in this, you can experiment with them. Yeah. So we'll few examples. Okay, let me go to that link and let me try it out. So I'll share another systems screen. Just a second. Can you give me share permission for the other laptop as well, other login as well? Users. Organize. Can you hear me? Can you hear me? Just a second. Yeah, can you see the screen? Can you see the screen?
Yes,
Yeah.
madam.
Yeah, thank you. So this is the tool. Okay. So you just need to click on file and then click on a new, and then you'll have the workspace out here. Okay. By the way, may I know how many of the students attending know this tool? Feel free. Do they have access to the mic? Okay. So these were the widgets I was talking about. Okay, the model, evaluation, and so now how do you use them? You just need to drag and drop a file, a CSV file. Okay, just drop any widget you want into the working space. Got it? That's it. And then to link two widgets, you just need to click on one and then hold your cursor, drop the cursor, and then send it till the data sample. That's it. You can connect any widget to any widget. Okay, there must be a logic, but just I'm telling you how to connect the widgets. Okay, so right now we'll examine certain models. Like for example, you can see here. So what you should do is click on the data category first in the left side plane that I have just shown you. Okay, and then drag the widgets into the canvas, and then click on the visualize category, and then drag the scatter plot. There's just one simple sample that I have created for you. What does this actually mean? Let us see. Like for instance here, so look here, you have I'm creating a new one. Let me create a file. Then you can see as here a lot of data sets are already available. Okay, iris data set and so on, they are already loaded. Or you can select any of these data sets which come along with the tool, or you can create your own data set as well. I'll show you that stuff. Okay, so let us select any. So this is the simplest. We'll take iris data set. is all about a flower data set. You have 150 instances. Look, when you load the data set, you can see that there is a lot of information available about the data set itself. How many rows are there in this data set? How big is the data set? How big is the data set? 150 instances. Okay. How many features are there in the data set? 4 features. What are they? Sepal length, sepal width, petal length, and petal width. There are 4 of them. So what is this exactly? Let us see. Like, so let me show you what this actually means. Okay. So this is the data set, and so this is one flower called setosa. Okay. Here they are defined. I'm in the mute mode, sir. Yeah, now I think can you see the screens now? Can you hear me? Okay. So Satyapras. Yeah, scatter plot. Okay. So you can just click on it and then decide your own. Anyway, do this with yeah. So I would click on file, okay, and then I would load a particular data set. You have many data sets, right? You can make use of any of them for experimentation. So this time I have taken heart disease data set. So what are the columns? You can see the information, all of it here. What does it have? Data on the presence of heart disease in the patients. Yes, the tool name is Orange Data Mining Tool. Okay, someone has posted in the chat window. So we have these columns. Okay, columns, parameters, features, they're all the same. We have 303 instances. Ikkachudan. In the middle, you have 303 instances. Ante a table lo, data set lo, you have 303 rows. And you have 13 features. Means columns are 13, rows are 303. So these are the columns. Look at these. Okay, diameter, thal, major vessel, something like this, ECG, age, ender, chest pain. These are all how many? 13 features first, right? So now this data set we have loaded. Now let us look at the data in the structured form, right? You can see the data, right? So these are all 303 patients data. So now see this. Certain data sets may have blanks, like when somebody is typing or some form is being filled by a customer or a patient. Certain fields we leave blank, right? So that means you don't have any data in that particular cell. So that means a question mark or a none, okay, means there are missing values. By mistake, you might have omitted it, or internally, because the data is not available, you might have put it. So when you have such missing values, the models that are built, okay, the decision boundaries might change. So what is normally done is certain like averages are replaced, those blanks are filled with average values, okay, or median values, or some kind of a number, okay. for that, what we do is we have a function. So we have what is called as, let me draw that. So what we do is we use an impute. Okay. So, and then we draw a link. So from our file, we have imported data, and then now we are imputing it. Okay, so we are trying to replace all those missing values through some programs that are written in this impute module. Okay, right. Then in this impute, you can actually mention, you leave the data as it is. I don't mind even if there are blank value, missing values, or as a distinct value. Ante ee data with some number like 999 instead of giving some wrong value. Or you can look at this average or most frequent. Okay, so in that particular column, the most frequent number is something. Okay, that with that we'll replace, or an average will replace, or we'll replace it with 10 always, 1 always. In that case, you take a fixed value. Then model based impute, random values. So you can choose any of these, and impute algorithm or module will actually take care of replacing all those values in those columns of the data set. Okay, so I'm applying it, and then now you have all the missing values replaced with our average, right? So I have used average or most frequent as the default method to fill the gaps. Okay. What next? Next, we'll see something about training the model. So we may have 150 flowers for the iris data set, or the heart patients data set, we have 303 patients data. You'll be training your model, building your model with part of the data, and then test it with the remaining part of the data. Like for example, you have 100 objective type questions which are available with you. So your teacher gives 70 of the questions to you for studying with answers. Okay, the remaining 30 she'll be putting up a test later on, but you have not studied them till now. So you're looking at those questions for the first time. So that means you're splitting the data means 100 objective type questions with 70 of them for your own learning purpose. And now whether you have learned properly or not, for testing, we consider the remaining 30 objective type questions. Okay. So training and testing set means the rows that we have in the database and in the data table. Okay. A few of them, 70% of them will be used for training the model, and remaining 30 will be used for testing. Okay. So yeah, I can now use any sampling thing. We can pick out certain data sampler. Okay, so what I can do now is I can pick up. Now look at this. Can you see the screen? Look at this. Okay. Look at this slider. You can reduce it. You can increase it. Maximum is 100 anyway. So I can So the normally preferred split is 70-30. A few models take 80-20. Some people use 60-40. It all depends on the size of the data set and the number of features and how rigorously you want the model to get trained. Okay, it all depends on the data set. So I have taken 68, 69 and 70%. Okay, you can see this. Or you can use fixed sample size. So from 303 heart patients data, you can say I want 200 instead of 70%. Or, and then I'm picking up this sample data and you can see now. Okay. So what we have done till now is we have loaded the heart patients data set and then split into 70 and 30. So we took a data sampler with get, then sampling type, we have selected fixed proportion of data, and then we set the slider to 70%. So that effectively makes 70% training and 30% testing. Okay, and then we submitted. Okay, so now I'll take the data table. I want to see how much data is there. So yeah. Okay, I'll take the data table, right? So how many data tables you will be having? 2 data tables, right? So I have 303 heart patients data in the original table. Then I said 70% is split into training data. Okay, I'm calling it as data table 1. I'll take another table and I'll say this is 30% of the data set. Now the first one is what? My training data set, and the second is my testing data set. Okay, now I'm putting my widgets and then linking them up. Okay, so those 303, 70% will be in the first table, 70% in the second table. Okay, now click on this link. So what do you see? You have data sample. Okay, and link it to this. ఈ రెండో దీనికి ఏం చేస్తాం, రిమైనింగ్ డేటా. ఓకే, రిమైనింగ్ డేటా విల్ click to data. So now what will be there here? How many? 213 instances. 213 heart patients data has come to the first table. Okay, so 13 features. Only the rows we have divided. Then we go to the second one. Look at the second table, the testing table. How many? 90 instances. They are put in this table too. Okay, this is called as training and testing split. So training normally has more number of rows. You have seen na 213 some number has come out, right? So 200 plus rows, they're selected for training, obviously, right? For testing, you require only 5 questions, but for training you require how many? Lot of material is required for training. That, as simple as that. Yeah. So this is about loading the data sets, then seeing them in a structured form, and then seeing them in a visual form, and what else? Dividing that into train and test data. So we have done the data preparation. We also replaced the missing values with average values. Okay, we have processed the data, pre-processed the data. What next? Now we'll try to build some data sets. Okay, so the best thing is like what you can do is you can generate your own data. Maybe you're measuring rainfall data. Okay, put them in an Excel sheet, then export it as a CSV file, then import here in the orange tool. Okay, you know the import this one, right? In the data category. You can use that and import, as simple as that. So till now we have used the data sets that are there available in the tool itself. But sometime you want to do some small project and experiment, right? Stock market prediction or something else. Then you can use this CSV file import. Got it? You can also type them. Small data set is you can. I have prepared this. Can you see this, everyone? Can you see the notepad file? Please help me out. Yes. So what you can do is you can save this as a comma separated value file. You can just say file and save as. Okay, file and save it with some name. That's it. That you can import it to your Orange Data tool. Got it? So this is another way of uh, building your own models for your customized data set. But remember, whenever you're saving it in notepad file, you have to put that name in the double quotes and then say whatever Titanic.csv has to be put in double quotes, and then you'll have all files option. That you must remember, otherwise it will not get loaded into the tool. You got it? Always save the name with double quotes. Yeah. Don't save it as text, remember. So I have prepared one data set called Vizag Bikes data set. Okay, so what did I do with that? So I can import, okay, Vizag Bikes data set. Let me create. Okay, I'm loading it from the desktop. Vizag. Okay. We'll create a new one. It's already running, so let me delete it. Then draw a new module. So let me open a new file, then load my own customized data set. Okay. Let me reload it. So, uh, will build. We have seen Orange data mining tool. Now you can do this very simply, even with Collab tool. Collab comes along with your if you have a Google login, Gmail login, okay, you can create your own Collab sheet. So I have prepared this byte data set, okay, with certain names of colonies in the Vishakhapatnam city. So I said there can be customers and subscribers who subscribe every month for a particular bike rental agency. So it is like source is RK Beach to, so there are different places like YMCA, Uda Park, Tenneti Park, Kailashgiri. So I picked up a few of them which are around the university. Okay, so we generated a data set. Okay, so this is the data set. You can see on the right. Can you see on the right? Very simple, right? So you have trip duration in seconds, start time, stop time, start station ID, station name, okay, and station name, and so on. So there's a data set. Now I can configure this and use it in either the Collab program, Collab tool, or I can use it in Orange tool. I can use it in Veka tool. Talk about any uh, tool, you can use the same data set and do the same kind of analysis. Okay, so yeah, so created the data set. Now process the data set. Okay, what do? We read the CSV file and then these are all the parameters or column names. Okay, and what else? You can now do all the cleaning and pre-processing which we did with Orange tool directly with the visual interface, right? Now here we have to write the code from the scratch. This kind of a code is already embedded in those widgets. That is why it becomes very simple, right? So what I am trying to do is, load that whole data set. So all this code which I have shown you is taken care of by the file widget. ఇప్పుడు దాకా నేను చూపించిన కోడ్ అంతా కూడా ఫైల్ widget it does it automatically. Got it? And whatever I'm showing you now is done by the data table widget. ఈ పోర్షన్ ఉంది కదా, this all by structured form లో చూపిస్తుంది డేటాని. So then whatever I have shown you with the scatter plot and those distributions, okay, that for that I have to write all this code. These are the visualization. What did I do? So I said distribution of the trip duration. Okay, I have drawn the histograms for it. and then user type breakdown. Okay. Then gender, how many male, females take the bike rental. Okay. Peak hours, what are the peak riding hours? Then for all these combinations of features, I have drawn the graphs. So what is the advantage? That kind of which Orange Data Mining Tool gives you. Okay, so there are a few of them are fixed, but when you write the code from the scratch, it's fully in your control. You can do a lot of stuff like this. So what is this exactly? So this is about distribution of the trip duration. Okay, so so morning before 10 o'clock, sorry, 10 minutes duration, 20 minutes, 60 minutes. Okay, how long the trip is. So people take a ride for 10 minutes or 5 hours. Then user type, how many are subscribers who pay monthly subscription fee, how many are direct customers, and then gender distribution, how many are male and how many are female. So looking at the file, it becomes difficult to make out all this, but these visualizations help you in really learning the story of the data, right? And then which hour of the day, what are the peak riding hours. So around 10 o'clock is the peak ride, and then evening 5, 6, 7 o'clocks, they're more, right? It's distributed, right? And then number of departures. So from YMCA Junction, how many people leave? From RK Beach, how many customers are there? From Andhra University Gate, then Jagadamba Center, MVP Colony. So you can make out where the bike should actually reside, so that you can have the customers immediately. You can reach out to the customers immediately. So where your bikes have to be positioned, right? And the rider age distribution, అంటే ఏ వయసు groups వాళ్ళు they take the rentals. So um, you can see here 25 to 30 is more like, right? So below 20 is less. You can see the distribution of rider's age. So this is all the data that we were seeing here, but that is a pictorial representation that helps you in making the decisions further, right? The same thing we do with the Orange Data Mining Tool as well. Okay, so then after visualizations, you can also take up some questions. So you can have some quick insights like total trips, okay, and average trip duration, most popular station, what is the busiest hour. So most popular station is MVP Colony. Average trip duration is 25 minutes. Average. Okay. Some people go for 5 minutes. Some people go for 5 hours. Busiest hour is 10 o'clock. Total trips on that day, because I have generated data of 1000 rows. So it has given me total trips as 1000. Now with this, you can make out certain decisions. Something like November month, how many trips? In 2024, how many trips? 2025, how many trips? 2026, how many trips? What are the changing patterns, behavioral patterns of the riders? All of that, you can have quick insights. I just put some questions like what are the most popular pickup locations across the city, so that you can ask your rider, bike people, okay, to put up stalls at those locations for rentals. And how does the average trip duration vary across the different age groups? So age group which age groups rents the most bikes, and how does bike rental vary from two user groups, and then does user age impact the average bike trip duration. So like this you can do a lot of analysis on this stuff. Yeah, so yeah, for each of those questions I've written some code, and now you can make out this stuff. What does this tell you? It tells you top 5 popular pickup locations. Okay, so yeah, they are MVP Colony, Jagdamba Center, Andhra University, RK Beach, and YMCA Junction. These are the top 5 pickup locations. So average trip duration by age group, like, so this age group, how many trips? Okay, 6 to 35, how many trips? And yeah, the last group is actually taking up the bikes for more time. Like this, you can also do an analysis on which type of a bike people are preferring to take on rental. Okay, uh, like which age group is preferring what kind of a bike. So you can put up those bikes at that particular place. Yeah, a lot of analysis can be done with this stuff, right? Yeah. So let us quickly go to another model. Yeah. So let me share this. There is another tool called Google Teachable Machine. So like we have seen how to write the code from the scratch and have full control of whatever visualization, whatever decision making, whatever detections we can do uh, using the bike rental data set, which we created for YJAC, right? And we have also learned how to make use of a tool which already has some models trained, right? And that is the Orange tool. Now we have very interesting tool called as Teachable Machine. This is a web-based tool. You don't have to install it, right? So when it comes to Orange data mining tool, you need to go to this website and then install it into your machine. Okay, you have to click on a download, and then based on which OS you have, you just download it and install it. Very easy. And you'll get that tool which I have shown you. It's a web-based tool. You don't have to install it in your machine. And this creates machine learning models faster, and no coding is required. Again, you need not worry. Even if you are a BA student, you need not think that you require coding or programming skills. You just need to know how to use an electronic gadget. Anyway, you know how to use a smartphone, right? So this is automatically easy for you to learn. It's totally running on the web browser without needing any powerful hardware, and it can recognize images, sounds, and poses. So like How does it work? You need to give some input data, train the model, and export the model. Okay, so you can create certain classes. Actually, this tool makes use of a technique called as transfer learning. What is transfer learning? Some model is already trained on certain other input data, and then when you give your data, so that model is slightly polished. So it can learn your new data and then use that old logic and still do some predictions and detections. Okay, so this simple. You need to gather input, collect the input, then train the model, and then export or deploy the model in your web application. Again, it's very simple, and right, so it trainings can happen using your own webcams. Okay, so I'll show you one uh, model. It's called pose detection, right? So what I can do is I'll share it just a second. So go to teachable machine. I'm looking at just a second. Okay, this is a simple, very simple model, right? Just go to teachablemachine.withgoogle.com. Okay, only thing you need to do is, like, you can save and do that stuff. Just say okay, you'll get a home page like this. .withgoogle.com. So you can run all these. Okay, you can classify images using your files or your webcam, right? You can train these models. So I'll run this. Okay. There are tutorials also. So what you can do is try on any of these models. There are many help models also given. Lot of tutorials, lot of blogs exist, right? Yeah. So you can start, or an already existing one, you can open that project too, right? So this is what I did. What did I do? I have used 3 classes, straight and right. So what did I do? I have trained, I'll retrain it again. Okay. So I'm holding to record and then training on the left tilt. Okay, I'm bending my head to left. So look at 85, 186, 205. I can also adjust these settings. How many frames per second? 24 frames per second. I can reduce it, I can increase it. Okay. Yeah, you can save the settings. And then now that you have 225 pose samples, I can go to another class. So I look straight now. New samples getting added. I have released. Now I'm training towards right, my right. Okay. Yeah, done. So I have 64 samples for right, 110 for straight, 225 for left. Right. Now I can train the model. Remember, it pops up an alert like this, don't switch tabs. So that means you should not go to another tab. Otherwise, you have to retrain it. So it's getting trained. Your model, AI model is getting built. So this is all based on transfer learning. Means they have already created some models with certain other images. So training is already done. Okay. On the top of it, a few sample images which it has collected through my webcam, it is adding to those set of layers that are on which the model is already trained. Okay, the model is trained. Now testing. So look at this. You have three outputs. What are the three classes? Left, straight, and right. Okay. Now when I am moving towards right, towards left, right, so straight, okay, right. So there is some, like in the training, I have given certain, left and right tilts also. So, okay. So now you can see left, straight, you can see the bars below, right? Now, based on some textures, certain points, it is able to classify whether I'm tilted towards left or right or straight. Okay. So this is a simple model which is called as a teachable machine, and you can save it, right? You can download this project. You can again have a lot of videos which help you guide, like, okay, you can watch those videos also. Then you can export this model. You can deploy this model somewhere. Got it? So yeah, there is one already deployed one. I'll show you. Like somebody has already done. They have published in this blog. Okay. So you can do this stuff. I think we are done with time. So yeah. So these are some of the exercises that we have put in the syllabus. So and learn AI, even if you're an engineering student, isn't it? Correct? So any questions? So yeah, one question. also predict certain things, like I have already shown you the crop yield data set, which has got certain parameters called rainfall, temperature, fertilizer, yield, right? You can as well again make use of orange, load these columns, okay, then set a target, and then you can directly do a prediction as well. Okay, let me show you that. So with this, we'll also close. Okay. Now look at this. So here I have loaded some crop yield data set. Can you see the data set? This is another data set which I am showing you. This we can use for prediction. Okay, you have rainfall, temperature, fertilizers in kgs, and yields. Okay, so you have 4 features. So what do we do now? You need to predict. Predict means you need to know which of these columns you want to compute based on the others. So like yield in tons will be your target variable, and then the input variables will be rainfall, temperature, and fertilizer. So what do? We the data set, right? We now have these features, 4 features, right? So what did I do? These 3, I kept them in the features pane, okay, and yield, I have yield in tons, I have put it in the target. So the 4 features that we had, one of them I have put it in target. The remaining are in the features pane. So what next? Now I have clarity that input will be 3 columns and the output is the uh, yield in tons. Okay. So I have selected the columns. Then I have tested. So you have one widget called as test and score. So I have told you, right? We need to measure how good the model is. So I have chosen the linear regression model, and mean squared error, root mean squared error, all of these are computed right away. And R2 value is 0.987. What does that mean? A high R2 value means the model is doing well. Okay, so 0.987 is a good score for a linear regression model. So this is the model build, right? And what do I do now? I can use a predictor. I can use a predictor, and I have used a linear regression model. I can set the regression parameters, but I have set it to no regularization. And I have selected the condition. Okay, so that if rainfall equals 1200, what is the prediction? So I have added the predictor from the widget, and now I get yield in tons is 4.5. Actually, we can add more conditions, but for the sake of simplicity, because the first year students are there, I have used a simple condition, right? So this is using linear regression. we can, what do? We compute the yield in tons, right? So like this, we have lot of things that can be done, and but yeah, we are almost there. So we'll stop here. Any doubts, any questions? I'm open. If you want to write the Python code, look, this is all what you should do to do the same kind of a prediction. So with this, we have learned how to do prediction and detection, right? So we learned how to visualize the data. We learned how to read the class boundaries, decision boundaries. Yeah. Any questions? Okay, if there are no questions, can we Anil Garu, are you there? Okay, thank you then. అయిపోయిందండి.